Hi everyone, welcome to this D2iQ Ksphere demo. The goal is to show you how to go from 0 to cloud native ready in less than 30 minutes. So if we look at the portfolio we have in what we call the Ksphere portfolio, we have Konvoy to deploy a Kubernetes cluster with all the tools you need for monitoring, logging and so on. Dispatch, a new software we are launching for CI/CD, and KUDO, which is an open source project we have started to be able to deploy distributed services like Kafka and Cassandra and Spark on top of Kubernetes, and Kommander that allows you to deploy additional Konvoy clusters, manage their lifecycle, but also apply permissions across multiple clusters and so on. So let's go deeper in these different solutions. So Konvoy will deploy a Kubernetes cluster with the logging stack based on Elastic and Kibana, the monitoring stack based on Prometheus and Grafana, Velero for the backup, MetalLB for load balancer on premise, traffic for the ingress, and everything is fully automated, the deployment and the lifecycle using Terraform and Ansible, and you get full support from D2iQ. About this dispatch software we will launch, we have followed this GitOps approach that you can see here described in this slide. And basically what we do is that we have like a repository on GitHub, for example, and you automate the CI part with Tekton, and then we have another repository and we automate the CD part with Argo, and you'll see that everything is being defined. Your full CI/CD pipeline is being defined in a single file. You'll see it's really powerful. Then we'll use KUDO, which is an open source project, to deploy Kafka and Cassandra in the demo. And KUDO is an open source project. Anyone can deploy Kafka and Cassandra, but with D2iQ you can get best technology support on all of these different technologies. And finally, we'll automate the deployment of our Konvoy cluster using Kommander, but Kommander can do much more, like managing the permissions across multiple clusters, the secrets across the clusters, and we'll soon also be able to manage service mesh and so on. So if we look at the demo, what we are going to do is that using Kommander, we will deploy a new Konvoy cluster, and then we will deploy on this cluster several software we need, like Kafka with KUDO and Cassandra with KUDO, a Minio cluster as well, and we'll use Dispatch to build and deploy our microservices that will allow us to have our application up and running. And basically this application, what it does, you have one microservice that gets pictures from the Flickr API and write these pictures on Minio cluster, and we configure Minio in a way that you get notifications, or you get messages produced in the Kafka topic when there is a new object created. Then we have another microservice that consumes this topic, download the objects, extract some GPS location information, and store everything in Cassandra. And finally we have another microservice that is our presentation layer that gets the information from Cassandra and display the information in the map. And we will have two versions of our application, so we'll be able to show with Dispatch how we can go from one version to another. So we go to Kommander here, you see the dashboard. Currently we just have the cluster where Kommander is running, but we want to deploy an additional cluster for this demo, so we just go there, we click on create a Konvoy cluster, we select our provider. I already put all the credentials there so that we can use them. We can select the availability zone, we can say the name of the cluster, so we'll just say Ksphere demo. We can have several node pools with stent and labels for them. Here we use like a little bit more machines to be able to deploy everything we need. We can even add some labels, and with these labels basically you can create what we call projects in Kommander that allows you to have like global namespaces across multiple Kubernetes cluster if you want to have like secrets deployed on all of these namespaces, permissions apply across clusters, so that's really powerful. So just click on continue here, and as you can see, what is happening now is that the cluster is being deployed, and the way it works is that the infrastructure provisioning is done by Terraform, and then Ansible is used to deploy the Kubernetes cluster and all the add-ons that we discussed before. And you can follow the deployment by just clicking on view logs, because everything is stored on Elastic, and we can use the Kibana cluster running on Kommander to be able to follow the deployment like you can see here. Currently this is the log of Terraform. Okay, so we have our cluster deployed, and we can see here the different information about our cluster in the logs. We'll be able to access that page directly in the future, but it's still a beta version of Kommander, so that's why it's still need to go there through the log to get the user and passwords. So just doing that very quickly here, taking the user, password, and being able to access the Konvoy cluster deployed by Kommander. And you see we can use like the access the Kubernetes dashboard very quickly, so version 1.15.4. We can access like the Grafana dashboard, where we have like a lot of nice dashboards for Kubernetes, but also for the other add-ons like Prometheus and Velero and Traffic, so getting a lot of information, a lot of insight that simplify the management of your cluster. And what we can do here as well is that we can download the kubeconfig file like that. Then we can just configure kubectl very easily, just using this file just downloads. So convoy dash, and now I should be able to interact with my Kubernetes cluster. Good. So from there I will use some scripts to deploy the different components we need for the demo. So I don't need to initialize KUDO itself because it's part of my cluster by default. What I'm going to do here is just to install Zookeeper and then check that the Zookeeper is being installed correctly. So I just go there, run this command that will install Zookeeper really in a few minutes. I can even follow that with this extension of kubectl. It's called kubectl KUDO. Plan should be something like plan status -- instance equals k, and I can see I have a deployment plan in progress that is going to deploy my Zookeeper, and I can also follow the deployment by just looking at the pods being created by the corresponding stateful sets. And this is already done, in fact, so I can just check that here if I want, and I can see I have my Zookeeper running. So next step is to deploy Kafka, so very easy as well, kubectl KUDO install Kafka, and again I'll be able to follow the deployment of it with either looking at the corresponding plan. Here I see it's in progress, and again the same way I can just use these commands to just follow the deployment and see also when the pods are being created. And what you can see here is that compared to Zookeeper, which all the instances, all the pods are deployed in parallel. In this case, we have like a serial deployment because this is the way Kafka technology needs to be deployed. Okay, so Kafka is now deployed. Again, it took like 2-3 minutes to get a cluster up and running. I'll just create a service monitor to get some metrics stored in Prometheus. This is something we provide with the KUDO Kafka. And basically I just need to import this dashboard in my Grafana. So I just get that here and say here I want to import a new dashboard. Just paste that content here, select the Prometheus data source, and here I'll be able to see my Kafka cluster in a few seconds or minutes, just waiting for the first metrics to come into Prometheus. So in the meantime, I can continue. Next step, we have the Minio operator already deployed on Konvoy because we use it to store the Velero backups. So I can very easily just create an additional Minio cluster, and I can again just follow the deployment of it. That should take also again like just a minute or two. You can during that time take a look at our Kafka stuff. Not there yet. So Minio is already deployed, as you see, very quick. I'll deploy KUDO Cassandra just to show you a different approach. Here we specify a different namespace and we deploy it with the local files of the KUDO operator. So in the other examples, I just say go online and find the latest version. In this one, I say, okay, I want to install this specific version that I downloaded in the past, and I can also specify some additional options. In the past, in the other deployment of Kafka and Zookeeper, I just say like do with the default, but here I say no, I want to have like specific values. So again, just run this command. Again, I can use the the plan command to flow the deployment, and I can take a look at the pods being created. In the meantime, I can also see that here my metrics are now coming for my Kafka cluster, and I see my 3 brokers. So this was the goal of that. So okay, Cassandra is already deployed. Again, was very quick. Here I'm going just to expose the Minio cluster to the external world. Like you can see, I just changed the definition of the Minio service to do that. And then I just need to wait for that service to be created and for the corresponding URL to be resolved by the DNS. So just do that here. Again, it should take like less than a minute. It just provision the load balancer on AWS automatically because I changed the service type to have a service type load balancer instead of a service type cluster IP. In the meantime, I can go and take a look at my Kubernetes dashboard here, and I can see that I have like some services deployed already, the stateful set corresponding to my different services, the persistent volumes that have been created for them, and so on. So really you can see after like 5 minutes, 10 minutes, I've been able to deploy like most of the software I will need for my application to run correctly. Okay, we are done. So what I'm going to do now, I'm going to use the MC CLI, which is the command line from Minio, to configure it with this service type load balancer I created here, and I just say I want to notify this Kafka topic when there are objects created, and I will just restart Minio. So quite straightforward. Again, configure it and reconfigure Minio to be able to produce the messages in the Kafka topic. Then I get the endpoint of Minio, and I'm going to update my deployment scripts in my GitOps repo to use this Minio service here. So I'm just going to do that here. And what I can do now is what I've just forgot to do here is just to create a bucket on Minio and to add events. So I want to notify for all the objects that have a GPG suffix. It's not for all the objects, it's just the one that you express here. So I just finalize the Minio deployment that way. And I push my modification about the external Minio endpoints here. And I'll go through this repository in more details and so on. So we are ready now. We can start to deploy dispatch. You'll see a lot of pumpkin command line and pumpkin file because this is the initial code name of the dispatch product. So the first thing we do is just we initialize it. Just one command and it will deploy everything on Kubernetes. And what you can do is that you can go back to your dashboard here and you'll find that there is a new namespace created for it, and you can follow what is being deployed there. So just wait a little bit and we'll see everything there. As you can see, like I described before, it's based on ArgoCD, Tekton and many other stuff, and with a lot of glue in the middle that is really interesting, as you will see in a few minutes. Okay, so now everything is deployed, so I need to configure a few things like my GitHub credentials and my Docker credentials and things like that. So I'll just go through that very quickly here. And then what I see is that I create several GitOps apps that you can define one repo for each app. But what I decided to do instead is to have one repository for my application that is composed of several microservices, and to create one GitOps app for each microservice by specifying the path in my GitHub repository. And you see the path is defined there. So same repository but different paths, and I can just create my apps there. I just run it again, but it works. So now I can add my apps, and what I can do in the meantime, I can go through my cluster here, take the same path, but just adding the path for Tekton, so we'll be able to follow what happens behind the scenes. So nothing has run for the moment, and the path for ArgoCD. And here we can see my applications are being created when I create my GitOps applications. And what's interesting to note here is that my applications are composed of nothing for the moment. Okay, they are defined, but there is nothing that defines what needs to be deployed and so on. So this is where it starts to be very interesting. So I have my two GitHub repos. One for my application and one for my deployment, so what we call a GitOps repo. So my application is composed of these three microservices, and basically I will deploy them. And to deploy them, what happened is that when I configured dispatch, it has created here a webhook. So whenever I will modify one of my microservices, then it will trigger the build and deploy. So what I'm going to do is that I'm going to just modify slightly one file in each of these microservices to make sure I trigger the build and deploy for them. So I'm going to just go there and say just modify this file, just a comment, just to make sure there is something modified. And so the map, and then the last one is this one. So just going to change that. And now if I go back here and I do a git status, I see that these files have been modified. So I then do a git commit, and I can do a git push. And what happens there is that automatically it will look at a file here. It's currently called pumpkin file, will be dispatch file in the future, and that describes what needs to be done. And then if you go in Tekton, you'll see here the pipeline run starting soon. Okay, so I see automatically, because of the webhook I get on my repository, I see that there's this build that starts for the different microservices, so the map, the Flickr, and the photo. And the way it works is that we get this magic pumpkin file that we can use different languages to describe it, and it's really powerful. So some of these options are necessary now in the alpha, will not be needed in the future, but even currently it's really straightforward to understand the concept. So you get like your source repository, so where you are, you get you describe your different apps or microservices. You can do like a loop here, and I say define a resource Docker image for each of these service, and I define my GitOps repo here. Then I can say for each of my microservices I define a build task where my input is my source repository and my output will be the Docker image I build. This is just like the process to build my Docker image based on my repo. And then I have a deploy phase, deploy task for each microservice. In this case, my input is my Docker image I built just before, and my GitHub repo that I want to use that define how to deploy my app. And finally, I say for each one, I create an action when I have a new push on my master branch. I want to be building and deploying my app. So really straightforward, just one file that describes my full CI/CD pipeline. So I go there, I see it has already been built, my first microservice, and then my Docker image has been pushed, and then my deployment has been done. So what happens now, I have this GitOps repo, and automatically I get pull requests created for each of my deployments. So what I'm going to do now is just to merge this pull request. I could have just said as well, I just want to have like the change committed to the master branch without any pull request and so on. It's just, you know, best practice to do that way. In fact, when I did my modification of my app, I should have probably followed an approach where I create a pull request and so on. I just wanted to simplify it by just pushing my modification to the master branch. But you can really then define the workflow that makes more sense for your organization. So I'm going to just merge these pull requests here. And in fact, if I look at the file, what I merge is these templates. And you'll see in a minute, I'll explain you what it means exactly. So just doing that, and it will be automatically detected by ArgoCD here, and ArgoCD will deploy my app on Kubernetes. So the way it is defined, how I deploy it, is with this GitOps repo, and here you can see, for example, for my Flickr microservice, I have this template file, and this template file has some parameters that are filled automatically by my pipeline. So the image name, I don't know the image name now, but it is being created by Tekton here with a digest, and it is passed there so that it is replaced when I deploy it. And this is my deployment description. It can be a deployment with an ingress and some other objects and so on. And basically this final YAML file is created from the template so that you see my image is replaced here. And what happened with ArgoCD here is that it's deploying the different components. You see this one has like a deployment with 2 pods, but then there is also like a service and so on. So it is just going to restart because it's waiting for some dependencies. And I can now just take a look at my pods. Everything should be running, and I can access my application. I use the same ingress, so just do like Ksphere demo map, and I can see my first version of my application where I get the different pictures from the sunset. And if I click on one, then I get, you know, where it has been taken and the number of views and stuff like that. So quite straightforward, but the more I wait, the more I see pictures coming, because they are being, you know, downloaded using the Flickr API, and then they have been processed and so on. And it's not very nice. I'd like to have a better version of this application where I can consolidate these things. So let's see how I can now make a quick change on my app and just push that. But I just want to modify one microservice in this case, not all of them. So I just go there and I use this new version of the index.html called v2 that is supposed to display everything in a better way. And again, just commit v2, do git push, and automatically I'll see on Tekton it will detect it. What you can see here is that this time it has triggered a build and deploy only for the map microservice, because I've just modified this one. So we'll just need to wait for it to finish, and it will create again a pull request on our GitOps repo, and then it will be discovered by ArgoCD, which will update the application in production. So you see I'm going to the GitOps repo now. I have a new pull request. This time it only changed the Docker image, which is the new one that has been compiled. So I'm going to merge it. And this will be discovered by ArgoCD here. For this app, it will discover that it's out of sync, and it will resync it, and it will do a rolling update of my map application. So you can see that it has discovered a change. Now it is creating the new containers, the new version, and doing a rolling update. And it is done. So if I look at my application, it was a little bit messy with a lot of points everywhere. So I can just go refresh, and I should have something far better if everything works well. Yes, you see it's just like a new version of my presentation layer, where it's a lot easier to zoom and to access the different pictures with my sunset from everywhere, like this nice one from France. So just to summarize, what we've been able to demonstrate is that we've been able to deploy like a fresh new Kubernetes cluster with Kommander in less than 15 minutes. Then we deployed like a Zookeeper cluster using KUDO. It took like a few minutes. The same for Kafka, the same to get Cassandra, the same to get like a full CI/CD software up and running, and then probably like around 5 minutes to do the first build and deploy of the application, and another few minutes to just update it with my new version. So really starting from zero and getting everything we need to manage the lifecycle of our application in less than 30 minutes. Thanks for listening and watching this video.